Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, what I'm going to be going through is VRRP, which stands for Virtual Router Redundancy Protocol. And for me, what does it do? The answer is really in the title. It's a protocol that provides redundancy to connected devices, to ourselves, to the hosts, to the users that are using network connectivity. And it's also providing that redundancy through or by the means of a virtual router. So I'll put this into perspective, into an example. If you're in your office and you are connected through a switch, and that switch eventually gets to some layer 3 router, in a single homed router environment, if that router fails or that link goes down or the routing table fails, etc., then you as that connected user, you can't then access, for example, the internet. You can't access all those cloud resources, OneDrive, Salesforce, etc., to do your job. So what VRRP is doing, Virtual Router Redundancy Protocol, is it's providing redundancy by having multiple routers provide a virtual router through using a virtual IP address. And that allows, if that single router actually goes down, the link is disconnected, the routing table fails, whatever, it allows for a backup router to step up, take over, and actually still provide that connected host with network connectivity. So for me, this is an absolutely superb protocol. And I'm saying that because not only is it quite easy to understand, yes, if you read the RFC, you're going to get into a lot more nitty-gritty detail, but from a high level, it's really easy to understand the concepts of what it is and how does it actually work. But you will also see it's actually very, very easy to configure and actually validate. And that's what I'm going to be doing in this video, is first going through the VRRP theory, what it is, which I pretty much just explained, how does it work, what are the benefits to it, of course, and how does this compare to other non-standard protocols such as hot standby routing protocol and gateway load balancing protocol, both proprietary protocols from Cisco. But I'll also be going through how you configure this VRRP in Juniper Junos devices and validate that. So for first, to begin with, let's actually start off with one or two friendly slides, just going through the theory, and then we'll build up from there. So here we go, everybody. Let's start off with the theory of VRRP and build up from there. And if you're wondering what the RFC, the request for comments, is from the IETF, the Internet Engineering Task Force, is that it's 9568. So if you fancy falling asleep and reading a lot of pages of really nitty-gritty, low-level information, please read that RFC. Like any RFC, they're incredibly detailed. But we're not going to do that here, obviously. But essentially, the role of VRRP is to provide redundancy for connected devices. Now, this diagram over here, this is actually the lab setup. This is what we are going to be configuring in this video. And right at the bottom here, you can actually see that there's a user here with this IP address from this /24 subnet. And right at the top here is the internet. And in the video, what we're actually going to be doing is we're going to be pinging an IP address that we all undoubtedly know, 8888 being Google, and we want to ensure connectivity is there. And all this traffic is coming up to the access layer switch, and it's being tagged, and then it's going over one of these two interfaces, and both of these, just so you know, are actually a trunk interface. So both the GIGI 001 and GIGI 002 are both trunk interfaces. But right here, router 1 is currently, it is set up to be what is referred to as the master. I'll come on to that in a second. But coming back to the point of redundancy, is if this router fails, if that interface goes down, or maybe this interface goes down, or it loses the next hop IP address to get to the internet, is that as this traffic comes up from the user, switch 1 can then forward that traffic over to router 2, which will be the backup. And that's essentially what VRRP is doing, is it's allowing these two routers to speak to each other using Virtual Router Redundancy Protocol to establish which one is going to be the active router, or what's called the master router, and which routers, or router in this case, is actually a backup. But what is this concept of a master router and a backup router? Well, the master router and other documentations refers to it as active. For me, it's really the same thing. But the master router, so when we go into the lab and set up router 1, R1 here, it's going to be that master router for the VRRP. And what that is doing is it's allowing the traffic to be forwarded from the user, yes, through the switch, but it's forwarding that traffic in and out of this particular network. But then there's these backup routers. So as I said, if this router goes down, this interface fails, there is that VRRP connection going from the active router to the backup routers, and then router 2 would then become that new active router and forward the traffic through there. But there's really, well, there is a limitation, but I can't find an actual value for the amount of backup routers that you can have in a VRRP group. So what you could have as well is, say, another router here, let's just call it R3, and if that switch was connected up here and then it had a connection to the internet, if this then fails, is that obviously at this point R3 could then forward that traffic on to the internet. But that's essentially what VRRP is doing, is it's having one active, one master router that is forwarding the traffic, and if that should fail, that backup router is stepping up, taking over, from moving from backup to active, from backup to master, and then we'll start forwarding that traffic. But how is a master router actually elected? Just like with spanning tree protocol, I've done a few videos of that recently, you need some kind of value to elect, well, who's going to be master and who's going to be backup. Now, not like the STP world where lower was better, in the VRRP world, higher is actually better. So what there is this range from 0 to 255. Now the default on Junos is 100, so if you don't actually configure that priority value of router 1 or router 2, by default it's going to be set to 100. But the highest, the best that you can actually have is 255. The lowest or the worst priority value you can have is actually 0. Now there is actually a use for the 255, and that is if that router owns the IP address. So we can actually see here, and just to put that into English, what does that mean? The Virtual Router Redundancy Protocol virtual IP address is 192.168.10.254 in the /24 subnet. Now what this means, if the router owns the IP address, is, say, the interface here, the GIGI001, if this had the 192.168.10.254 address assigned to it, then we could actually assign the priority for this particular router, for this VRRP group, to be 255. That's what's meant by owned. So just be aware of that value. Yes, you can configure it to be 255, but that's only really if that router has and owns that IP address. But in the event that this is configured to 255 on router R1, but router 2 also has 255, well, obviously there's a tie there where both values are the same. So if there is a tie, then the higher the IP address actually wins. So if GIGI001 had this 254 and GIGI001 had, just for example, 192.168.10.1, just for example, just a random number, then obviously this value over here is going to win, and router R1 would then become the active or master router. And here's the number of groups that can be configured from 1 all the way up to 255. Now, I don't actually know if it's possible to have 255 VRRP groups supported on a single router. For me, why would you actually need that amount? I think that's very questionable, but certainly read documentation on that vendor, on Juniper Junos for that particular hardware model and software, etc., to see what is the recommendation on the maximum amount of VRRP groups that you can actually have. But coming back to it, we've got the router R1 as the master, and it's going to be master again because it's got this priority of 254 versus router R2, which has this priority of default of 100. And what happens is when router R2 knows that router R1 is the master, it's not sending out any VRRP advertisements. It's just there sitting, waiting, and listening to these advertised ownerships, these messages, these hello packets that router R1 is sending out. And by default, of course, you could change these timers. It's sending out these hello messages every 1 second. Now, some documentation refers to this as the hello ownership advertisement. Other documentation from different vendors describes this as an announcement, as a keep alive message. Potato, potato in my mind. I'm saying it how it is. The end row, the function of this message is for R1 to notify router R2, I am still here, I am still here, I am still here. And at any point, well, not at any point, but within a certain period, and I'll come on to that in just a second, if router R2 stops hearing these advertisements, these hello or keep alive messages, then it's going to assume that router R1 is no longer there, it's no longer reachable, and it's going to take over. It's going to move away from the backup row, and it will become the new master. And I almost gave way to it just then. I said I was going to come on to it in just a second. So these backup routers, they have something called a hold time, and that is when they're just holding on to that last received message that they got from the master or active router from R1. And by default it's set to 3 times the hello interval. So if the hello interval, that keep alive interval, is 1 second, obviously here this is then going to be 3 seconds, isn't it? Of course, it's simple maths there. So what this means is if that router R1 has sent a keep alive message, R2 is going to wait 3 seconds, and if another announcement hasn't been received in that 3 seconds, then router R2 is going to take over and become that backup. It's redundancy at the end of the day, and to have that redundancy for ourselves, for these connected devices, you've got to have a mechanism in place to A, notify that a device is still there, and B, really a device to step up, come into action if it stops hearing of that active router. But where does the master router forward those packets to? Well, there is a multicast group, 224.0.0.18. This is the multicast IP address that router R1, I keep saying router R1, but router 1 will forward its announcement message to, its hello message to. And it doesn't matter if there's another, but just one more backup router, or there's R3 and R4, and however many backup routers there can be in a VRRP group, is that all these routers, these backup routers, will be there sitting and waiting for 3 times that hello interval to receive that hello message through this multicast IP address. And of course, this is the IP layer. There's got to be a MAC address associated to those packets, and this is the multicast MAC address 0000580001. Now the last 2 8 bytes, so this is actually 8 bytes here, it's hexadecimal values, is that this would be set to that group identifier. So here in the diagram you can actually see what we're going to do in the lab is we're going to set up our VRRP group to be group 1. So then here, using that multicast address group, is that it's not going to be XX, of course it will then be 0, 1. If this group was 11, just for example, it would then be 1, 1. or maybe a bit different actually because it's hexadecimal. But you get the idea, is that the x-axis representing that VRRP group number. And this is absolutely superb. This is something that I really, really love about VRRP. Is it's not just looking if a router goes down, it's actually able to track objects, as it is called in documentation. Now by objects, what it's actually referring to is the interface and to a particular route. So what does this actually mean in English? Well, we know router R1 is going to be that master router because it has the best priority. And what we are actually going to do in the lab is that we're going to track this interface. So we're going to track the GIGI 000 interface. And if this goes down, and this is what we're actually going to do, is we're going to disable that interface. Do you notice there, and it's tracking that GIGI, it's tracking that GIGI 000 interface. So if this goes to a down state, what there is there's this priority cost deduction. So we've got the priority value of 255 here. And what this basically does is say, I'm going to deduct a particular cost. So if we deduct 254 from that priority value, then suddenly that priority value is going to equal 0. And at that point, the router R1 is going to no longer be the master. It's then going to be the backup to the new active router, that is router R2. And it's not just for interfaces, you can also do it for routes. And we're not going to do this in the lab, just for your information. So over here, there's actually a quad 0 or default route of 000/0 pointed to this next hop IP address on this interface here. So if this route goes down because this IP address no longer becomes reachable, then it's no longer going to be active. It's no longer going to be valid in the routing table, and thus it would be removed. And so then you can actually deduct a cost from that priority value of router R1. So again, let's say the router goes down, not the router goes down, but the routing entry goes down, and then you can deduct another value of 254, just for example. And at this point, again, that's no longer router 1, it's no longer the master router. Router 2 would become the master router because this priority value would no longer be 254, it would now be 0 because that has had a priority deduction from this tracking. So yeah, very interesting. So not only does it VRRP work in the case of a router actually going down, but through VRRP you can track objects such as the interface and also the routes themselves. And you can maybe even back this up with something called BFD, bidirectional forwarding detection, but that's not in the scope of this video. And I did say during the intro I was going to compare VRRP to hot standby routing protocol and gateway load balancing protocol. I think that's what GLBP actually stands for. But the big point I will mention straight away, and this isn't going to be new information, is that HSRP, as far as I'm aware, and GLBP for sure, are Cisco proprietary. Yes, HSRP is defined in this RFC, but GLBP came from Cisco. It only works with Cisco devices for sure on GLBP. HSRP, I think, still works for only with Cisco devices. And there are obviously going to be more differences than what's shown in this table here. But if you look at load balancing, yes, you can get that through GLBP. Obviously, that's a plus. Fair play, Cisco, for that one. IPv6 support. So this isn't correct. Actually, this image. So there is IPv6 support in VRRP. It's called VRRP v3 actually. But from a transport perspective, HSRP is using UDP, as is GLBP, but actually there's no TCP or UDP header with VRRP. It's actually just a IP routing protocol, so only at the network layer using this protocol value of 112. And the default priorities, that's the same. That's nothing to really worry about. But the default hello, you could see the differences here: 3 seconds, 1 second, and 3 seconds for those different protocols, and the multicast IP addresses here. Now, it is pretty much recommended, depending on your network, that you actually change these values. And the reason being is depending on the amount of groups you've got, VRRP groups, is that 1 second could potentially put a bit of stress on the forwarding engine. So maybe you want to relax that timer just a little bit, but obviously it's a balancing act, because if a router goes down and you've relaxed that default hello interval and subsequently that hold time interval, where it's 3 times as long as that hello interval, it's going to take longer to converge. So yeah, a little bit of a balancing act. And there's also this concept of preemption. What is that? And it's enabled by default on VRRP. What preemption basically is, and we'll do this in the lab, is that we are going to disable this interface, aren't we? That's what I've said. And when that's disabled, we're going to have a cost reducted from the priority value here, and that's then going to be 0. And at that point, R1 is no longer the active master router. R2 will actually be that active master router. Preemption is when this interface comes back up. This deduction is suddenly no longer valid, so the priority would then go back to being 254. Preemption is basically router R1 would take over as that master router once again. It would take over from router R2, which would then become that backup again. So that's basically what preemption is it's able, in the VRP world, is it's allowing a higher priority router R1, to take over ownership of being that master to forward traffic when a route, or when an interface, or when itself as a hardware perspective comes back up online. It's just going to take it back over from a lower priority multi-layer switch or router. And obviously this is important, authentication. We have VRRP packets going back and forth initially. When you start the VRRP process, actually, both routers, router R1 and R2, just like the SDP world, they assume that they're going to be the master router. In the SDP world, a switch will assume it's going to be a root bridge. And it's only when it receives through a protocol data unit and receives those priority values that a router decides, I'm not active, I'm not master, I'm going to be a backup. But we want these messages going back and forth to be authenticated for obvious reasons, for security. So there is none, i.e. there's 0 authentication. Or you can do plain text. So there is authentication, but it's plain text. It's not hashed. I don't want to say encrypted. It's not hashed. So if you were to do a packet capture, a PCAP on this interface, and there was, I'm just going to do PT here for plain text messages going back and forth from router R1 to router 2, then a hacker or a person with any capturing tool is going to see what that password is. Or there's MD5, multi-digest 5. Not really the strongest hash algorithm going. Maybe there's a newer RFC coming, or that I just didn't see, where stronger than MD5 is supported, but at least then it hashes that password, whatever that password is, and it's not then readable on a packet capture. And finally, and I've kind of alluded to it, is that you can fine-tune the VRRP intervals. Now I'm actually going to show right at the end, just very quickly, some documentation from Juniper where it states, how you can change the skew. We'll go through what is the fast interval. Basically, it's where you change the interval of those hello packets coming from router R1 to router R2. And it's no longer going to be 1 second, but it's going to be sub-seconds. It's talking about milliseconds. But again, balancing act. And then there's these other concepts such as the advertise interval, which is that hello or keep alive message. That hold time, we've already gone through that. But then there's these other things, asymmetric hold time and silent period. We'll quickly go through this at the end, but I'm not going to spend a lot of time there. The point here is that you can fine-tune VRRP for those messages, and more importantly here, those timers, to have that best balancing act possible for your network. So that's the theory around VRRP. It's the whole concept of active master router with a number of backups. Higher priority will take ownership. If there's a tie, is you looking at the next value, which is the higher the IP address, actually wins. And really, VRRP is providing redundancy to this host. So if a interface goes down, if a route is just removed from the routing table and you're doing tracking in VRRP, is that backup router steps into action and becomes the active master router, and thus the user can keep forwarding traffic. And even though there will be a slight hit, at the end of the day, you still have network connectivity. So now let's actually move into the lab and start configuring this. Okay, so let's now get into the configuration of VRRP. Specifically, what we're actually going to be doing is first starting off with this access layer switch with switch 1. And this is important because we need to configure this interface here, the GigE000 interface, to be an access interface with VLAN 10. Then what we're going to do is configure these two interfaces here, GigE001 to router 1 and GigE002 to router 2 to be, and as I said before, these are going to be trunk interfaces where VLAN 10 is going to be trunked over. And then on router R1 and on router R2, but we'll start on router R1 first, we'll do it a bit quicker on router R2 following that, then we're going to configure, yes, that's VLAN 10, but we're then going to configure that layer 3 interface, that IRB, that integrated routing and bridging interface. And what that basically does is it allows VLAN 10 to have a layer 3 interface, and thus router 1 and router 2 will act as that gateway. So we're going to configure IRB 192.168.10.1 on router 1 and IRB.10 192.168.10.2 on router 2. And then we can actually get into the VRRP configuration, such as configuring this virtual IP address and the priority and the group, so on and so forth. What we're not going to be configuring is basically everything up here. So I've already configured, this is actually, I'm cheating here to be honest, it's just an internet logo, but that is actually a router that's already configured, and the interface is here, 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 and here already configured with us IP addressing, and really backwards and forwards from the routers to the internet. It's all static routing. I'll show that, but it's already configured, already in place. But for now, let's start off at the beginning with switch 1, and then we'll go from there. And this isn't going to take any time whatsoever. So I'm on switch 1. I've not put my secure CRT onto switch 1, but it doesn't really matter. And let's go into edit VLANs, hit a quick show. There's no VLANs there. So I would need to create VLAN. So I'm going to do set VLAN 10, VLAN identifier, not VLAN 10, but VLAN identifier 10. Do a quick show. That's the VLAN configured. Now if I just do top edit interfaces and do a quick show, you can see there's no GigE interfaces here. Now the GigE000 interface is facing user 1, so we need to define that. So let's do set GigE000.0 family Ethernet switching interface mode access with VLAN members v10. And now I need to do the same, but it needs to be a trunk interface for the GigE001 and GigE002 interface. So let's do set GigE001.0 family Ethernet switching interface mode trunk VLAN members v10. And if I just hit up, do Control A and do the same for GigE2, and that's it. I've now just configured very quickly the switch 1, the access layer switch, to bring in the untagged traffic from user 1 and to align it to VLAN 10, and then trunk all that traffic associated to user 1 with tagged traffic VLAN 10 up to router 1 and to router R2. But let's just do a commit and quit on that, and now I can move over to my secure CRT. Here we go, here's my command line interface on my secure CRT. I like this display a little bit more, but let's go into the command line interface, into configure mode, into edit VLANs. Do we have any VLANs? We do not. So let's configure that VLAN 10. So let's do set v10 VLAN identifier 10, and we need the IRB interface, integrated routing and bridging .10 interface. So for that we do layer 3 interface IRB.10. And if I do a quick show, that's it, that's that VLAN configured there. I also just need to now configure that GIGI001 interface, which is going down to switch 1. So let's do top edit interfaces, let's do a show here, and I've already got the GIGI000 interface, which goes to the internet. As I said, that's already been configured, that's already there working, but we don't have the GIGI001 interface. So let's define that. Let's do set GIGI001 family Ethernet switching interface mode trunk. It's exactly what we've done on the switch, VLAN members v10. And just to show you, if I do top show routing options, you can actually see I've got a default static route for all traffic, and the next hop is 172.10.20.1, which is the interface connected to the internet router up the top. But if I actually just do a quick commit on this, and it's actually committed it, and if just to show you, if I do a run ping 88, not 777 but 8888, we should have connectivity to that Google server. It's not actually a Google server, I am cheating a little bit, but you know, it's a lab at the end of the day. So we have now configured router 1 with that GIGI001 interface. Where do you actually configure this IRB interface? Because under the VLANs we configured the VLAN to have a layer 3 interface with IRB.10, but where do we actually configure that? That's actually in the edit interfaces. So what I could do is do set IRB.10 family INET address, and you can see the address of 10.IRB10 on router 1, that's 192.168.10.1/24. And let's just do a quick show, and here we go, just there. Now where do you actually configure VRRP? This could catch you out a little bit, because if I do top edit protocols VRRP, this is virtual router redundancy protocol. But if I do quick set, there's no interface here, there's no priority, is there? And that's because this is where you are fine-tuning VRRP, or maybe setting it to use version 3 for IPv6. Where you actually configure VRRP in terms of the priority and what interface to use is actually inside the interface itself. Now that interface isn't the GIGI001 interface, because that's layer 2, that's Ethernet switching. So if I go back to edit interfaces, or top edit interfaces, and do a quick show, you can see the GIGI001 interface, which goes down to switch 1, is Ethernet switching, it's layer 2. So where do you configure VRRP in this particular lab? It's done so under the IRB, because VRRP is a layer 3 redundancy protocol, and IRB is a layer 3 virtual gateway. It's a virtual interface. So let's go into edit IRB.10 family INET address 192.168.10.1/24. Now if I do quick set here, note here, the VRRP group. This is where we actually define that VRRP configuration. So let's do that. Let's do set VRRP group. We want it to be group 1. Hit question mark, and now you can see all the extra detail. So track, we are going to do this in a few minutes, but we could define the priority here. We could say this is preferred on this particular subnet. We could do preemption or no preemption. We can say we want to accept data, which is important for pinging, the authentication key and type, and quite a bit more. But for now, let's actually just do priority. We want this to be 255, and we want to also set preemption. And under preemption, if I hit question mark, you can also then further define the hold time, which is 3 times that initial hello or keep alive message. But if I hit enter on that and do show, you can now see for this IRB unit 10, it's now got a group 1 with priority of 255, and we are preempting. I just note, I saw there it's supposed to be 254, so let me just change that. VRRP group 1, priority 254. Let's do a quick show again, and there you are there. So I just saw that very quickly there. What I'm also going to do is set the group to accept data. This is important because it will allow user 1 to ping this virtual IP address, and that's something that we haven't configured yet, because this virtual IP address is going to be 192.168.10.254. That's what router 1 and router 2 are going to share as that virtual gateway for user 1. So how do you configure this? Well, if I do set VRRP group 1, hit question mark, virtual address here, one or more virtual IPv4 addresses. So let's do virtual address, hit question mark, and that's it. You now just enter in 192.168.10.254. I don't have to do the /24 because it's inherited. If I do up to, and let's do up again, it's already inherited from this /24 at the end. That is the VRRP configuration done on router 1. So let's just go, actually let's just do commit and quit. And that is router 1 configured both with the GIGI 001 interface to be layer 2, with the IRB interface and the VLAN to have that layer 3 interface of IRB.10. And we've also configured that VRRP group 1 inside of IRB.10. But now it's gone to router 2, and let's do it a little bit more quicker just for repetition. And so let's do set VLANs v10, VLAN ID 10, layer 3 interface IRB.10 for VLAN 10, of course. And let's also set the interface, set GIGI 001.0 family Ethernet switching, needs to be layer 2 down to switch 1, interface mode trunk VLAN members v10. And now we need to configure the IRB.10 interface. So let's do set IRB.10 or set interfaces IRB.10 family INET address 192.168.10.2/24, and it's now define the VRP group 1 priority of 100. I don't have to enter that in there, but it's just because it's default, but let's enter it in anyway with preemption. And now let's move into that, show it. So let's move into edit interfaces IRB.10 family INET address, and there we go. And let's do a quick show, and you can see here it is here, but we also need to configure that virtual address, don't we? So let's enter that in 192.168.10.254, and let's do a show, and there we go. And actually if I do up 3 and do a show again, so we got unit 10 for IRB for VLAN 10 family INET with this physical IP address or logical IP address for the IRB, and we have VRP group 1 priority of 100. So router 2 is not going to be the preferred, but they are both sharing this virtual address of 192.168.10.254. Now if I do a commit and quit on this, and that's done. Now let's test this. Now let's go on to user 1 and see if we can ping that IP address of the virtual gateway. So let's do ping 192.168.10.254, and we absolutely can. We don't actually know though if that's going to, just from this display, if it's going to router 1 or router 2, because it's virtual, but we know from that priority it's going to be going to router 1. And on that note, how can you actually validate this? Well, a very good command you can do is show VRRP brief, and what you can now see is that the IRB.10, where we've got VRRP group 1, note it says group 1 here, it's up, it's running. Router 1 is currently the master, it's active, it's actively forwarding traffic. This is the timer that is expecting the next message to be sent out, because this is the master. And we can now see our local IP address 192.168.10.1. That's what we configured on the IRB.10, but that virtual IP address is 192.168.10.254. If we go over and compare this to router 2 and run that same command just to compare, show VRP brief, we can now see it's pretty much the same information, but it's saying back up here, it's active. This is the time that we are expecting to receive that message from the master, and we can actually see that master IP address here, 192.168.10.1, which is the IRB.10 interface on router 1. What are some more commands, more shell commands you can actually do? Well, if you just do shell VRRP and hit question mark, you can go into the detail. So we can actually see that we've got the address here. We can see it's using version 2 and it's active. The priority, virtual IP address, the uptime, the master router uptime, the virtual MAC address. Note at the end it's 01 for group 1. If you actually hit run that same command but do extensive, it's going to give you a lot more information. So you can see how many packets, VRRP PDU or protocol data units have been sent. So 320 already, and if I just run that same command again, you can see it's already more because it's doing it every second. And you can also see have there been any received, have there been any invalid, a lot more information. So yeah, so there's a lot of detail there. But if I hit show VRRP and do question mark again, you can also go into the interface and it's do IRB.10 because that's the interface, and we could see the VRRP statistics on the IRB interface itself. So yeah, very handy show VRP commands, and we can even do the track of this as well. And just to test, and it's not showing anything there because we've not configured tracking, but if I actually go onto router 1 and fail a swap over, what are we going to see on router R2? So let's go into the configure command and let's actually do set interfaces GIGI001 disable, and let's commit that. And with that committed, let's go back to router 2 and let's run that same command, show VRRP brief. And now you can see, because this interface here is disabled, that router 2 has suddenly become the master because it didn't have that hello message coming from router 1 within that timeout period of 3 seconds, and thus it elected itself as the master. But let's test preemption. Let's now re-enable that interface on router 1. So let's delete interfaces, GIGI001 disable, and if preemption works, router R1 should become the master again. So let's go back to router R2, let's run that same command, should have happened by now, and it already has. No, it hasn't actually, so let's do, there we go, so there it is, so backup there. So yeah, it's now the backup, and if we come back to router R1, run show VRRP brief, yeah, and now you can see it's back as the master. But let's make this a little bit more interesting in terms of configuration. Let's configure authentication and let's also configure some tracking. So let's go into edit interfaces, IRB.10, family INET address, 192, etc, 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 and into VRRP group 1. Let's do a quick show command and it's just to see the information, and let's do set, and here you've got the authentication type and the authentication key. Let's do the authentication type first and hit question mark. Note, there's no none there because you just wouldn't have this command authentication type if you were going to use no authentication. Doesn't make sense. But let's do MD5, hit question mark, and we can now say authentication key is going to be this particular value. So I'm going to call it netcademy. Let's do a quick commit check on this, and it succeeded. And I'm just going to go into router R2 and really do that same command. So it's going to configure mode, set interfaces IRB.10, family INET address, etc, 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 VRP group 1, authentication type to be MD5 with the authentication key of netcademy. And that is the authentication very quickly set up on router 1 and on router 2. I haven't committed it just yet because I want to show you how to track. So if I do set question mark, we can now see tracking. So what I want to do is I want to track the GIGI000 interface on router 1. So if it goes down, we are going to deduct a cost, and if it's significant enough, router 2 will step up as that master router to keep network connectivity. So let's do set track, and note here you could define an interface or a route. but I'm going to do an interface, and this is going to be the GIGI 000 interface, and hit question mark. I can now define the priority cost, and I'm going to deduct 254 from this. So the priority of router 1 is, if I do a quick show, is already 254, but if this interface goes down, I'm going to deduct 254, and then that priority is just going to be 0. So let's do a quick commit check on this. It's to make sure my logic is correct, and is, and I'm just going to commit and quit on here, and it's gone to router 2 and commit on that as well. And let's just quickly validate that we have VRRP actually running. So let's do show the brief command. We can see the local IP, this is active. Let's see if router 2 can see the same information, or thereabouts the same information. So yeah, we can see it's back up, and we can see the master is 192.168.10.1, which is router 1. Now let's test this failover, because what I'm going to do is I'm going to disable the GIGI 000 interface, and with that tracking, router 1 should step aside, should no longer be the master router, should fail over to router 2, but user 1 should still have connectivity to 8888. So let's go on to 8888, and let's do, I don't know why it keeps doing that, it's just EVNG for you, but let's do ping 8888, and let's do this continuously. So right now we are pinging from user 1 to 8888, and that is going through switch 1, of course, up to router 1, and then up to the internet and back again. But now let's actually disable this link, and we should see a slight hit on user 1, but then it should continue. So let's suspend this, and there you can see it's timed out, and there we go again. So I was getting a bit worried there, to be honest, but there was 3 times out. But now VRRP has failed over, and router 2, just by looking at this, has become that master router. And just to verify that, let's bring this up again now. Let's go on to router 2, run that same command, show VRRP brief, and yeah, it's now the master because we suspended that link here. And just for fun, let's go back onto here. So yeah, the ping is working from user 1 through router 2 up to the internet and back again. But let's now re-enable that link, and maybe we'll see another hit as it goes back, and it doesn't actually appear to be having another hit. So let's go back onto here, let's do router 2, run that same command, and it's still back up. And there you go, I ran the command a few times, but yeah, as you can see, every time I've done it, I think I need to get my eyes tested. I wasn't reading it right, to be honest. But yeah, it was back up, and you can see I ran it a few times, just wasn't reading it, to be honest. But it's now a backup, and the master is back to router 1. Yeah, that's it. That is VRRP. That is configuration and validation, and actually proving how it fails over when, just for example, an interface goes down. If you're tracking it, it deducts the cost, and if that cost is significant enough, it will fail over to a backup. A backup will then become the master. Okay, so we've got VRRP running, and we've validated it, and we've done the test of a failover, and we've ensured round-trip connectivity during or after a failover. Tracking is working. But the question is how can you fine-tune this? Because once you know it's working, obviously you want to fine-tune it so that you're not stressing the multi-layer switches or routers with too many VRRP groups and all those associated hello messages that are going through the packet forwarding engine and obviously to receiver. But at the same time, you don't want conversions to take too long. So back on router 1, it's going to configure mode, and it's going to edit protocols VRRP. And again, I'm just going to do set. I'm not actually going to do this, but as I mentioned before, there's quite a few different timers that you can change, such as the asymmetric hold time, failover delay as well. So what are these? Well, I'm not going to go through it all because obviously there's a lot to VRRP, but here is actually a document from Juniper, from the Juniper Networks information page. I'll link all this down in the comments box, of course. But here you can actually see to improve the convergence time of VRRP, it actually mentions things such as, actually configuring this periodic packet management process and disabling the skew timer, and maybe changing the number of advertisements to be faster, and configuring inheritance of VRRP groups. You can see there's a lot here, but coming back to it, the fast interval, and I said this before, this is where this would be more stressful on the forwarding engine because we're talking about milliseconds here. So the normal interval period is 1 second, but with the fast interval command, then this is in the interface, this would be milliseconds. So every few milliseconds, a PDU would be getting sent out. And what is this disable skew timer? Well, this is actually, you can see a note, it's only used when there's one primary router and one backup router, but skew is another word for deviation. So here you're disabling the deviation in terms of time for a backup state to go to that primary state. So you're just disabling that, so that's going to improve the convergence time. But then you've also got this startup silent period. So this is when, and you can see it, this is done within Edit Protocols VRRP. This is to ignore when an interface has been down and it's gone back up to the up state. Apparently there could be some errors or alarms or interruption caused by this. And here you're saying, I want to have a few seconds where everything's silent and I want to ignore all those alarms and errors, if any. And then configuring the asymmetric hold timer. And again, this is done within the set protocols VRRP. It's within the VRRP family, not the interface. What this basically does is it basically bypasses that hold timer. So the asymmetric hold time, if, as we did, if an interface goes down or bandwidth goes down or route just disappears from the routing table, primary router will fail over to, or the backup router would take over being master. And what this basically does is when that link comes back up, when that route becomes available again in the routing table, it allows that router, that master router, to avoid using that hold time, waiting for that to expire, and to immediately revert back to being what its previous state was as backup, and the previous master to resume, to preempt being a master once again. So as you can see, yeah, VRRP was very straightforward. When it comes to actually fine-tuning it, there's a lot more that you can do within the VRRP protocol family. So I'll link all of this down below. Obviously, read it, your networks, of course, read it, and to base your timers based on what you actually want to achieve. So that's it, everybody. That is the end of this video. That is the end of this part that I've done in VRRP, Virtual Router Redundancy Protocol. As always, I hope you found that useful. Hope you found that informative. We've gone through quite a bit of information in terms of what is VRRP, what benefits does it provide, really redundancy at the end of the day, and ensuring end users remain connected. And then, of course, we went into a bit more theory, the multicast group, the IP address and the MAC address, and how election is actually formed by priority first, and then if there's a tie, higher IP address. And then, of course, we went into how can you configure this on Juniper switches. This was on Juniper switches, so if you're doing it on MX routers, just for example, the syntax will be a little bit more different. Having said that, the validation commands will be the same. So I hope you found that useful, hope you found that informative. If you like my content, please give me a thumbs up. Best way to support my channel. Any questions or comments, let me know down in the comments box. I love hearing from you all. Other than that, thanks for watching and goodbye.